Okay, this is going to be a test of the fixed update method for physics systems within Playcanvas. This is something that I have been working on. I have not been working on this script. No, this was applied to me by a very generous individual within Playcanvas who wrote the script up himself. But something I've been working on my own projects is basically why have there been differences in game feel as far as the speed of the kind of physics impulses applied to a rigid body dependent upon the refresh rate of the screen. So the problem has been is that the speed at which, or speed, I'm not using the proper physics terms here, but the rate at which the force is applied is dependent upon the refresh rate. So a refresh rate of super high here, 240 hertz, is going to be 4 times as fast because every time that the screen refreshes, that impulse is applied or force is applied to the rigid body, causing it to build up more and more velocity with each step, compared to that if I'm at a lower refresh rate of 60 hertz, where it's only going to be applied 1/4 as many times because of that fraction that it is in compared to the higher refresh rate. So this is going to create a different game feel as well as a different kind of data collection ability dependent upon refresh rate of the screen. Most things are 60 hertz, that's true, but definitely you will see that that's going to vary for a variety of reasons come individual gameplay. So right now I'm set at 60 hertz, which you would consider to be the standard. The way that this script works now, this app works, is that here's a fixed update method where I can set the fixed step. Okay, and then that fixed step, which this script here is applied to the box, is called box, as you can see within the script panel here, then applies a force of gravity to the box where it will fall downwards, as you can see here. I'm going to print to the console the new fixed DT that will demonstrate exactly what the time step is, kind of a face validity for how the manipulation of this will manipulate the application of this, which will then have its effect on this. So the point is that you should be able to consistently see regardless of how the refresh rate changes. If I keep the fixed update step the same, then the way that the box falls on the screen should also look the same as well. Okay, so I'm at 50 hertz here, and I am going to keep it at 60 hertz here, and that is saved. I'm now going to launch it, and you'll see there it falls. Let's look at the console. 0.16, 0.17 thereabouts. That's about 50 hertz. Okay, now I am going to change this to 48 hertz. I'm going to keep those changes. Everything's still saved. I'm now going to relaunch the app. And you see now, because the fixed update of 50 hertz, and I believe is above that of the refresh rate, it's not getting caught, and this box will not fall. Okay, so let's go back to, again, 60 hertz as our benchmark, and keep those changes. You can see here again in the time step updated. Nothing happening. So again, when I change my refresh rate, or it did fall, sorry, it did fall, right? It fell like it did before. Putting this back to 50 hertz, 48 hertz, refresh. Nothing happening. Clicking in the screen, nothing happening. It's not falling. Okay, so now I'm going to change this to 240 hertz, which is ridiculously high, I know, but it's to emphasize the kind of relationship between what would be considered normal versus a high performance screen. right? Okay, 50 hertz, it's the same. If you saw that, okay, fell a little faster. That definitely feels and looks faster to me. Again, we're still at 50 hertz. I'm going to go back to 60 hertz. And the issue that this is now presenting is that this fixed update set is not effective at being able to do what we would like it to do. And that the way that this box should fall, given a fixed update that is below that of the refresh rate of the screen, should have the same feel of it, regardless of what the refresh rate is. But as we can see, that's not the case. One more time with now the super high refresh rate. Definitely falls faster. So this fixed update method, although trying to get at the right thing, and is in fact doing what it's supposed to be doing, right? It is doing the right DT, right? We're seeing 0.2, 0.17, somewhere around that. It's a lot more variable. Perhaps that's part of it. If I go back to this, keep the changes here, refresh. You know, same range of the DT. So the DT is not changing, but something else is happening, and I don't know what it is. Something to consider. But anyway, this is kind of concludes that test. If you have more questions or like me to run other tests, just let me know. I've appreciated all your help thus far. Hope we can find something about it, but for now, just keep soldiering through. Thanks.